Hi, welcome back to DevOps presentation series. This is Satyadev. In the last presentation, I talked about microservice architecture, how good it is, and in that presentation itself, you might have a sense that microservices fits well with DevOps culture, because DevOps culture talks about um, granular, speedy things development, speedy and granular development, communication, stuff like that. Microservices do provide all of that, right? So microservices is a good choice for DevOps. Now, in this last presentation of for Unit 2, I'm going to talk about how microservices DevOps talk together. Are there going any challenges? If there are any, what are they? We are going to are other miscellaneous things related to DevOps. We are going to discuss them in this presentation. Let's go to the first slide. Microservices and DevOps. In this presentation, following miscellaneous topics are discussed about microservices and DevOps relationships. The first one is Conway's law. Second one is forward compatibility of microservice interface. The third one is microservices and the data tier. The fourth one is DevOps, microservices, and resilience. So these are the 4 topics which I'm going to discuss as part of microservices and DevOps integration. Let's go to the Conway's law. Conway's law: structure of an organization that designs software winds up copied in the organization of software. So looks complex, right? Actually, it is not simple. Conway's law deeply connected with the microservice architecture, and it means if a module independent deployable system is needed, then organization and communication part should be support that. So that means basically you want a good system to be done, you have to have good communication. What Conway's law says is that the way you are organized, your software is going to be showing that. For example, the second point, bullet point talks about in building a microservice, 4 different cross-functional teams needs to be involved, right? Database, backend, front-end, and operations. These 4 teams needs to be involved. Now, if you look at the microservice architecture, you have all 3 of them. You have front-end, you have middle tier, you have the backend. Middle tier is nothing but the service component, several service components, right? So business functionalities, and the data access layer, and the database thing, right? So you have all 4, and operation team for CI/CD deployment. So that's what it talks about. So DevOps bring about 4 teams together. So if you are following a DevOps, you need to microservices really is the way you go with fit into DevOps, because when you develop a microservice, it shows your organization, database team, backend team. So the teams are how the teams are organized. The code is also organized that way. That's what the Conway's law talks about. Now, the next topic, forward compatibility microservice interfaces. In other sense, I'm going to explain why most of the microservices use REST protocol. I said protocol. Honestly speaking, REST is not a protocol. REST is actually an architectural style, whereas HTTP, HTTPS are the protocols. REST is built upon those protocols. REST is actually architecture, but some people call REST protocol. It's a general colloquial usage, but it's not a protocol. Anyway, normally any service, it could be a microservice or it could be a web service or TCP AP service, anything. Logic would evolve over a period of time due to business or technical or any other operation, which we discussed in migration thing, right? In order for a client consumer to use a service, the service should expose an interface of methods following a protocol. So, in order to use it, you need an interface like A, B, C, D, E, F, G, H. These are the methods that I'm providing to you. You use them to get this. You use A to get this done. Use B to, like this, use specify a method to add users, update user, delete user, do something, purge user, whatever operation, right? So that kind of, that's what it is. That's why a service is called a producer. Basically, a service actually produces a lot of methods for us to use those methods, right? It creates some interface and give it to us. So we use that interface and communicate with the service. So it's like a producer, right? So that's why it's called a service, is also known as a producer. there are many protocols that are available for interface exposition. In order to expose an interface, there are certain protocols. HTTP, HTTPS, which is REST based upon. SOAP, another protocol. WebSocket, TCP/IP. SOAP protocol, etc. SOAP protocol exposes data using XML, and REST exposes using text, JSON, many other formats. So REST actually is not a protocol but an architectural style of which I already talked about. So basically, REST is used in microservices because it exposes several things. When it comes to SOAP, WebSocket, they are more very strict protocols compared to REST. So since microservices talks about loose coupling, it is desirable to have these protocols to be flexible enough. Whereas SOAP and TCP communication or WebSocket communication are very rigid, and we have to follow it. And if you change something, then a lot of problems are going to be there. We'll talk about that in the next slide. When an existing method of a service interface evolves, data from the methods could change. That's right. One option is that consumer changes its code for consuming new data. However, this puts burden on the consumer. Now, what is consumer? Whoever calling the interface that provided by a service is the consumer. Service is the producer, and service produces an interface, and consumer consumes that interface. That consumes basically means calling methods on the interface. That's nothing but, right? So, for example, you have an interface. Let's say there is a service, business service, maybe shopping cart service, which provides an interface. Add to the card, remove from the card, increment the count, decrement the count, like that, or delete, something like that. Like it provides some methods. This is the interface. So it produces an interface of methods to us. Now I am the front end. I am going to call add, I don't know, pen to this card, add this book to this card, then increment the pen count to 3. Now I'm calling the methods on the interface provided by that. Now you want to change this interface so that while adding itself, you add the cost. So you change the interface. Now the data that you get from the thing also could change, right? So in that context, let's say if a method signature changes, then what consumer needs to do is it has to change its code. Let's say for now, add item method takes only item code. For example, now tomorrow, not tomorrow, but later in the future, they said item as well as the price. They added another parameter to the method. Like 2 parameters now added. Now, previous interface is containing only 1 parameter, which is the item code. Now, 2 parameters. My existing client code won't work because I am only calling method with 1 parameter. Now, one option is change my code so that I add a second parameter. Now there is another option. Server could add 2 methods. One is keep the existing one, add the new one. That actually make the interface cluttered. You don't want to do that. So it's good to have only one method that takes item code and price as one thing. So consumer has to change its code. That is one thing. This such kind of consumers. So the producer should expose data in such a way that without changing the existing data format, it needs to augment the new data format. So basically, shouldn't however this puts burden on. See, because I have to change my interface, it puts a burden on me, right? As a consumer, that means as a UI, I have to change my code. So the producer should expose the data in such a way that without changing the existing data format, it needs to augment the new data format. So basically, like I said, you create 2 methods. For one for only code, item code, another is item code and price. You do that, and you have another method called set price for set price for this code, something like that, right? So you have to do that. So basically, what it means is make the consumer as a tolerant reader. Also, it is required for the consumer to implement tolerant reader pattern once just for the first time. In order to avoid that problem, what we need to do is implement tolerant reader pattern. So for example, let's say the producer is giving data. Now earlier in the old code it is giving AB. Now it is giving ABC. Now as a client I might get confused, right? So what I could do is just ignore C. If even if it is there, just ignore C. That's what tolerant reader is. So implement tolerant reader pattern so that you don't get to this problem. This way an interface can be made forward compatible. So this can be forward compatible. So that client consumer code may not need to change even if a producer code is changed frequently. So this is how we can fix the uh, one set of problems. There are several other problems. This is one problem. So basically what the gist of this talk is about this forward compatibility. Make sure that the consumer and producer code, the producer code anyway is going to change because of the business needs which we talked about, right? Producer code is going to change irrespective of producer change. Make sure that take care in the consumer so that it doesn't need to change a lot. So that means make it a tolerant reader is one aspect of it. There are other aspects, but yeah, this is one aspect. Now, it would be easy if you use SOAP XML, then it would be difficult to use that. Now, if you use HTTPS4, it is easy because it gives a JSON or text or so that's the reason microservices go for REST protocol most of the time. So that's what it is. Now, another aspect of the previous topic is mostly towards justifying that microservices use REST over HTTPS because it is convenient compared to SOAP and other WebSocket architectures because it is flexible, whereas SOAP and other protocols are not flexible enough. So that's what the justification. Now this topic I'm going to talk about services and the data tier. General practice in microservice architecture is to use one database for microservice, which we have seen. As microservice, as a microservice caters to only one business functionality, the database that microservice uses has data related to the particular business functionality only. So, which we already discussed. This provides the benefit of separation of concerns and provides easier deployment. However, this architecture has challenge while aggregating data from multiple business functionalities to meet customer report needs. Now you have one business functionality, A, B business functionality, C business functionality. Now customer wants to see and you store them in database. You want to see all the data from ABC at one place. Now you have to go to A, get database and collect. B database collect. It's cumbersome, right? That's what it talks about. On the other hand, the traditional three-tier architecture, there is going to be only one database for all business functionalities. So it is easier to do data modeling and create desired customer reports using the three-tier architecture compared to the microservice architecture. So one challenge is with the three-tier architecture approach is lot of data synchronization needs to be, which we discussed, to be taken care. That could slow down the data access, especially for write operations. So we already discussed about it. When in three-tier architecture, when several instances writing to the same database, we need to make sure that they are all synchronized. Let's say they are writing to the same row of the same table. Then you can't just write parallelly, right? You have to stop one guy before finish, let him finish, then use another guy. That's how it should be, right? So it should be done in that manner, right? So yeah, so that's what is. Now here we are only talking about the merits of microservices and demerits. So we have seen two challenges. One is client may updates, customer consumer updates is one challenge. We haven't given any solution for these things. We are only talking about pros and cons kind of thing, right? So we are not talking about big solutions. One solution for the client, consumer is tolerant reader, which is okay, and use HTTP. That's another solution, but that's not the exhaustive solution. Just small solution. So another issue or another aspect of microservices is DevOps microservices and resilience. Microservice architecture is a great fit into DevOps as development and deployment could be done very fast. However, microservice architecture do pose some issues in the context of reliability. Since microservices expose more integration points, there are going to be more failure points, obvious. Even though as part of DevOps implementation, automated testing is employed, those tests may not provide any insight Why a service stopped suddenly? See, there are several microservice instances, all running, and let's say one service is down. Yeah, you have tested all the services thoroughly, integration, end-to-end component, everything is done, fine. But suddenly something is down. But those tests can't tell immediately why this is down, right? So you have to figure out. One solution to the our problem is to have monitoring daemon service, not daemon. Daemon means like ghost or anything like. Daemon means like background. Um, Daemon service that pulls a special monitoring interface of the actual microservice and takes the microservice out of load balancer if it is done. Yeah, this is the approach that's recommends. So for example, there are a bunch of microservices running. Suddenly one microservice is down. It is being load balanced. But its instance is still there, but it's not working anymore. How do you know it's not working? One way is you run another service, background service, daemon service, which keep polling all these services. And once it polls that, okay, this is down, just take it out of the load balancer. Maybe you create another one, add it, but take it out of the load balancer. So the daemon service can do that. This application makes this makes application more resilient. Resilient means capable of holding attacks. Apart from broken aspect of the service, the monitoring service also can monitor other application specific aspects such as database connections, state, etc., etc. So basically, you just don't need to confine that for, okay, is it live? Is it live? You don't need to just check only thing. Is the database connection is good? Is socket connection is good? Is configurations are going okay? All the dynamic pieces, are they working properly? It could also check. It could check the database if the tables are, properly is full or empty, something like that. The monitoring service could also monitor other generic aspects like CPU usage, memory usage, disk usage. So you can also do a lot of other stuff also, but predominantly service is down, yes or no. Data connections are, all the other connections and database aspects are good, yes or no. Apart from that, other generic aspects like CPU, memory, all that stuff, you can do that. So thank you very much. So this completes the architecture part of the microservices, part of the DevOps. So we have seen in this unit, we have seen what are the various architectures that are available, which fits really well into the DevOps architecture, and which we have seen that microservices architecture fits well. But we also noticed that there are certain problems with microservice architecture, and we have seen few solutions for that. But again, there are other challenges microservices which have got solutions as of now. Multiple options of solutions, but it is also outside the scope of the discussion of this presentation. So this completes unit 2. Thank you very much. Let's meet in unit 3. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.